Okay, so what I want to do, okay, so here we go. It's not hard stuff, but it's probably a good idea for us to take a second and look at everything we've talked about all year. Oh, you know what? Let me do one more thing. All right. Okay, so here we go. These are the kinds of questions you're going to see. All right, so they want you to, now you got to read these very carefully because the questions, they're asking for precise stuff. They're not hard, but you might accidentally think you're finding zeros and it's not asking for that. Like in this case, it says use factoring in the zero product property to find all real zeros. Now, you don't have to follow those instructions. All you got to do is find the zeros, the easiest way possible, right? So if we've got x squared plus 9x plus 20, if we're finding the zeros, that means we're just setting it equal to 0, right? And it wants us to enter exact numerical values of the zeros only. If multiple zeros exist, separate them with commas. If it cannot be factored, enter in, right? It can be factored, right? So this is pretty easy one. Yes, sir?
Are you supposed to be recording?
I am recording, yep. Okay, so, we could just, this would be an easy one. What are our magic numbers?
5, 4, 1.
So what are our zeros? So that's what we did, right? No big deal, okay? Okay, same kind of thing. Enter the exact numerical values of the zeros only. If the multiple zeros exist, separate them with commas. If it can't be factored, enter in. Same kind of deal, it can be factored, right? But we're entering the zeros. You're not entering factored form, you're entering the zeros. Same problem. We can just skip that. Okay, same kind of thing. They want you to enter exact numerical values. You want you to factor this. So this is one we could factor. Here's the, let me make the problem a little bigger. So it's 3x squared minus 58x minus 40, and they want us to find zeros. So we'd have to use bottoms up on this one, right? So with bottoms up, our magic numbers have to multiply to what? Okay, good. So they have to multiply to negative 120 and add to negative 58. So yeah, so negative 60 and positive 2 would be the numbers, right?
Yeah.
Negative 60, positive 2. So then we'd have to go through the whole process of completing the square. And so we would say what? Remember, we break it up into x minus 60 times x plus 2. But we got to divide both of the magic numbers by what?
3.
By 3, good. So this one reduces to x minus 20, and it's done. What do we have to do with this one? Bottoms up, 3x plus 2, and now we just set them equal to 0 and solve. So what would our zeros be?
Negative 2/3.
So 20 and negative 2/3. Okay, what kind of shortcut could we have taken on this one, of course? We could have just used the quadratic formula too, right? And that's fine, because it just wants the zeros. So you can just use the quadratic formula if necessary. So they're only looking for real zeros on all these problems, though, right? If you didn't get real zeros, but you will. They're going to work out to be real zeros. If you didn't, you would just put in on a problem like this. But you are. They're all going to be real zeros. In the whole test, there's very little imaginary stuff. It's a much easier test than the ones you guys did. Like I would have asked you for complex zeros on this. They're only looking for real zeros. Okay? Okay, completely, I mean, same kind of thing, we want to, this time they want to write it in factored form,
Yeah.
that's it. That's all they want.
Yeah.
So if we've got x squared minus 49, what factoring pattern are we gonna use? Difference of squares, yeah, so what's that gonna split up into?
X minus 7.
Good, because 49 is just 7 squared. So it's x squared minus 7 squared. Okay, so that's what we want for our answer. Questions on that?
Wait, when was it you said? Oh, never mind. I'm done. So let's just leave it like that.
Completely factored, right? They want it in factored form, so that's it. That's broken up as far as we can. Okay? Questions?
I'm wearing it.
Wait, is this practice run?
It is, yeah. Yeah, you can do it if you want it. It's fine. Yeah, there is a practice test. Okay, so this time they want you to, now this one's done for you, right? They're just saying solve the equation. Well, it's already factored. I mean, what are the answers gonna be? Yeah. 9/8 and 8/5. Okay. Right. Okay. So this time they want you to solve the equation, write exact simplified solutions. Okay, so this time it does say if the solutions have imaginary parts, just include I in your answers, right? But this is, this is pretty simple stuff. You're gonna probably just factor this, right? Solve by factoring, but your answer is the zeros. You don't want it factored form. Just read the question carefully. Write it. Solve the equation and write exact simplified solutions, right? So the numbers, okay? I won't even spend time on that though. For you guys, that's so easy.
So,
Okay, what about this? Find all real solutions of the equation below. Well, what are our solutions going to be?
plus or minus y squared.
Exactly. So we got to separate them with a comma. So you have to get both of them. That's the only way you could miss this one. You do square root of 43, which can't be simplified, and negative square root of 43. Piece of cake. Right?
Piece of cake.
Factor the expression completely. So what about one like this? Yeah, if we've got, here's the equation, or the expression 7x squared plus 35x. Now, if I'm factoring a two-term polynomial, either it's going to fit a factoring pattern, right? Or it's not, but we always want to see if we can do what first when we're factoring? What, greatest common factor. Yeah, and with a two-term polynomial, usually that's all you can do. So what could I undistribute? What could it be?
7x.
7x, okay, good. So we take 7x out front, what's left behind? X plus 5, so that's our answer, right? Okay? Okay, so it says find all real solutions. If no real solutions exist, enter in. Okay, we want exact solutions. I mean, what are the steps to solve this thing?
Add 12 divided by 3.
Add 12, divide by 3, square root, right? So I'm going to get two answers, plus or minus whatever that square root is. Do we need to do it? Everybody want to see it?
I does.
Okay, let's do it.
You're right.
All right, so if we add 12 to both sides, we get 3x squared equals 75. Divide by 3, I get x squared equals 25. So what are my solutions? Okay,
Cool.
Okay, so what about this one? Find the value of c that makes this expression a perfect square trinomial. So this would be like completing the square stuff. So what would I have to add there? Now here's how you think about this. I know this is not hard, but just kind of make sure we're thinking about it the right way. we want to pick the right number so that the magic numbers would be the same number twice. Well, what's our recipe for that?
13.
The number that goes there, call it C, has to equal what?
B over 2 squared.
Has to, okay, B over 2, so 26 over 2 squared. Well, that's just 13 squared, which is 169. How would you check it?
Plug it in.
Well, okay, yeah, you plug it in and then see and find magic numbers. The magic numbers that would multiply to 169 and add to 26 would be x plus 13 and x plus 13, which is x plus 13 squared. So we did it. We made it a perfect square trinomial.
Where'd that 26
That's the recipe. We always take half of whatever b is, right? Half of b. We're gonna whatever b is, we divide by 2, and then that result squared is the number that has to go there to make a
If it
perfect square
doesn't-
trinomial.
If it doesn't divide by 2 evenly, you just gotta do it.
If it doesn't divide by 2 evenly, you're gonna get a fraction.
Or
Okay, but on this test, I think it's pretty likely it's gonna divide it.
pretty likely.
B over 2. B over 2
Okay, what about this one? It says, find the value of C. Well, I mean, what's it gonna be? 81. Oh, and then hang on though, it wants you to, this is different. You gotta read I almost didn't read the directions. So on the last one, it just wanted the value of C, right? On this one, it wants you to write the trinomial as the square of a single factor. So we wanna write it as something squared. What's that gonna be? Yeah. So that's what they're looking for your answer, x plus 9 squared. So you gotta make sure you're reading the directions carefully, okay? Solve the equation. This one does say include i's if necessary. How would you do this one? Quadratic formula for sure, right? So do we want to do that, or are you good with that? Do it? Okay.
Let's do it.
So we get,
X equals
okay, what is it, x equals, start over.
B squared minus 4ac divided by 2a.
Very good, all right, there we go. Okay, everyone knows the song. So then if we want to get this thing simplified, let's work over here, how about, so we get x equals negative b would be negative 14 plus or minus the square root of,
216.
what's 14 squared?
216. Just kidding, I don't know.
196.
196.
Just kidding, I don't know.
Minus 4 times a times c. Well, 4 times a times c is 4 times 8 times 3. How about if we did 4 times 3 is 12 times 8 is what? 96, what do you know? Divided by 16. So what we want to do on these now, as long as, if we get an I, here's something else, just to kind of, we have talked about, I know you can all do this, but to be smart about using the quadratic formula, if we end up getting something under the radical that's going to turn out to be an integer, right, when we take a square root, so if we get a perfect square under the radical, then there's no need to split the fractions, right? Because we know we're just going to end up getting an integer plus or minus an integer, which is easy to simplify, divided by an integer, right? But if the square root doesn't work out nicely, if we either get i's, because we have a negative number under the radical, or we end up with having something stuck in the radical, so we get an irrational number there. Those are the times when you want to split the fraction up, because you're going to want to write it as separate parts anyway, right? Okay. So in this case, we get what under the radical? 100 square root of 100 is 10. So then we can just do it like this: negative 14 plus or minus 10 over 16. We'll take the plus sign. So negative 14 plus 10 is negative 4 over 16. So I get negative 1/4. If I take the minus sign, negative 14 minus 10 is negative 24. Negative 24 over 16 is what? Negative 3/2. So those are our answers. Okay? Make sense? Okay? Same thing, they want you to find all roots. I mean, what are we gonna do here? Doesn't factor, right? So this would be another quadratic formula one. So we would get x equals negative 8 plus or minus square root of 64 minus negative 16, right? Minus 4 times 1 times negative 4, so 64 plus 16 all over 2. So this is one where I'm going to get a square root of 80, right? So this time I'm not going to be able to split, I'm not going to be able to turn that into a single integer. Under the radical doesn't work out nicely. So let's break it into two parts. So we're going to get negative 8 over 2
Or negative 4.
plus or minus
Net 4.
the square root of 80 over 2. And the square root of 80, that's where we've got to use our little factoring tree, right? So what's 80 break up into?
42.
40 and 2, but we could probably do better than that. Why don't we do something like
20
at least
and 4.
20 and 4, okay. And then 20 breaks up into,
4 and 5.
so there's a couple of 4s and a single 5, right? So we end up then with
4 radical 5.
negative 4 plus or minus
4 radical.
4 radical 5 over 2. Well, the 4 over 2 reduces to a 2. And so our final answers then would just look like negative 4 plus 2 radical 5, negative 4 minus 2 radical 5. Right?
Yep.
Okay? Okay, so we're moving on to rational functions. This is stuff we've done pretty recently. Should be pretty easy stuff. So if we want to simplify this expression, what are we going to do?
Back to the bottom.
Say it again.
Back to the bottom.
Factor the bottom. The top's already factored, so we factor the bottom too. So it's going to work out to be x minus 6 divided by what? So what do we do?
Cancel out 6.
Okay, so our final answer is 1 over x minus 4. They don't even ask you for excluded values or anything like that, right? They just want to know what's the simplified version.
Really, that'd be bad if you just put X.
If you just put what?
X minus 4.
It'd be wrong. Yeah, it's 1 over x minus 4.
That's what it is. That's the
Okay, same thing, they want you to write your answer in simplified form. We're going to find the product. This is stuff you get, it is right up your alley, right? This is easier than most of the stuff you did in that chapter. So we're just going to factor top and bottom, right? So what do we get if we factor the top? We just get x minus 1 times, or x plus 1 times x minus 1. On the bottom, we're going to get, what's that factor into? X plus 3x minus 1?
Yeah.
And times x plus 2. So now what? Cancel those. And then in this case, whoops, in this case I think it doesn't say that we can, it wants it in simplified form, so that means it wants it expanded. So we gotta multiply it out, right? So our final answer then would look like,
X squared plus 5x plus 6 on the bottom.
yeah, so on the top we just get x plus 1. Here we'd multiply that out and we'd get x squared plus 5x plus 6, right? So that's our answer. Okay? Questions? I would think not. That's pretty recent stuff. Okay, so they do have you add up some rational expressions, but they're really easy ones. So what would we do here?
Denominators.
So we got to figure out what is the least common denominator. So we'll factor everything, right? So we get 5 over x plus 2 over x times what? Okay, so then what do I have to do to the first fraction to get a common denominator?
Multiply by the second. X plus 1.
Okay, I got to multiply top and bottom each by x plus 1, right? And so that's going to give me a common denominator of x times x plus 1. And on the top, just getting all that stuff, right? So if I distribute the 5, I get 5x plus 5 plus 2. So what's my final answer then?
Expanded out.
We got to expand it out. Good. So we're going to collect like terms. So we get 5x plus 7, and on the bottom, what would it be?
X squared plus X.
There it is. Okay. All right. So by the way, this is just a kind of a minor point, and we didn't go through any SBAC prep. This is usually where I talk about this kind of thing. But this is just a good strategy that you can use on any test, but when you start to think about taking SATs and PSATs and those things, what's a really easy way where you can check problems like this? You know of a trick? I got a great trick for you. Now usually this is not a test, you can't have a graphing utility on this test, but you do have access to a non-graphing utility, okay? Actually, I don't even know if you have that. I'll check, I think you do. I think you do. There's no harm in having a
Plug in
regular.
a random number.
That's it. Plug in a random number. And you were there for the SBAC prep stuff. You remember that? So you could pick a random number. You could pick a random number, and whenever you're doing something like this, where you're trying to just simplify something, right? You're not solving an equation. You're just rewriting this in a simplified form, right? Anytime you're writing an equivalent expression like that, you can always do a quick check to see if you got the right answer by just picking some random number, like let x equal 3 or something, right? Or 1 or something like that. And if I plug that in up here, and I get the same number that I get when I plug it in down here, is it a guarantee you got it right? No, but it's a pretty good, quick, easy check. Because if you didn't, if they're not the same, you know you did something wrong, right? That's a quick and easy way to make a check on on a problem like this. On problems where you're actually solving, what of course do we do? Plug them back into the original equation, see if they work. Okay? And even for problems like, what are we on here, 16? If I go back to one that's even a little bit harder, like, what was the most recent one where we didn't get a good answer, like 13 maybe? Was that the one? Yeah, there was one right there, right? Where we got a square root for an answer. Okay, how could you check that? You know, you're not going to, on a regular non-graphing utility, you can't really plug in an answer like, you know, with a square root involved very easily into this function. But you could just make it a decimal, right? You could, whatever our answer was, we got 2 answers, you could quickly find out what the decimal equivalents are. You don't have to go out to very many places, 1 or 2 places. Plug those values in for x, and if you get something that's pretty close to 0, you did it right. But it's not going to be exact because you're making a decimal approximation, right? But you get the idea. Where were we? 17's next?
17.
Okay. Find the quotient. Okay, so something like this, what are we going to do? This is, I don't know if we actually ever did one like this. So this is probably a good one to do. It's not hard. But what would you do? If I've got something on top that's kind of, you know, sum of fractions and something on the bottom that's sum of fractions.
Find the common denominator.
We don't have to do anything nearly that hard. I mean, on the top you do, I guess. Now you're talking about just on the top.
Yeah.
So we're just going to add the things up on the top, and we're going to add the things up on the bottom. But here's the basic rule on a problem like this. If you have what's called a complex fraction, where you get fractions on the top and fractions on the bottom, the rules are simple. Just take the top and turn it into one simple fraction. Simplify it into a single fraction. Take the bottom and simplify it into a single fraction. And then what do you do when you divide by a fraction? Flip and multiply, right? So it's no big deal. So on the top, and these are easy ones to add up. What's our common denominator on the top?
X.
X. So this, I got to write the 1. 1 over 1, I'm going to multiply by x over x, right? So on the top, we're just going to get x plus 9 over x, right? On the bottom, 5 is our common denominator, right? So I'm gonna multiply x over 1 by 5 over 5, so I'm just gonna get 5x plus 1 over 5, right? Now all I have to do is flip and multiply by the bottom, and I'm set. So my final answer then is just gonna look like whatever I get when I do x plus 9 over x times 5 over 5x plus 1. There are no common factors there to cancel, right? So I can't really simplify this thing at all. So I just multiply everything out. On the top I get 5x plus 45. On the bottom, what do I get? There's my answer. Okay. Make sense? So once again, strategy is just take each part separately and just, do the top completely, simplify it into a single fraction, simplify the bottom into a single fraction, flip and multiply. If you can cancel anything, cancel it. If there's like factors to cancel, but if not, then just expand it out, multiply it all out. Okay? Even though we didn't really do one like that, it's not a big deal. Okay? How about this? Find all valid solutions. Okay, so this is solving a rational equation. What's our strategy when we're solving a rational equation?
I said x.
Eventually, but what do we want to do here? Clear the fractions, right? We're going to find out what the least common denominator is. What is it?
X squared.
X squared. Because if I look at my denominators, I've got a 1 and an x and an x squared. Well, the least common denominator is x squared of those factors, right? So once I know what the least common denominator is, what do I do?
Put everything in one side.
No.
Multiply top.
No, what? I'm going to clear the fractions by multiplying through by the least common denominator, right? So if we know the least common denominator is x squared, we'll just multiply each side by x squared, right? What's that going to give me? If I distribute, I'm just going to get x squared minus, so what if I multiply x squared by 3 over x, what am I going to get? Minus 3x, good, because one of the x's is going to cancel, right? And on the other side, the x squareds will cancel, and I get a negative 2. So now I can just solve this equation. Oops. I can just solve this equation by adding 2 back to this side. Okay, now what?
Magic number, correct formula.
Magic numbers, or what are my magic numbers?
-2, -1.
-2, -1. So if I solve this thing, what are my solutions? X equals 2, 4, x equals 1. Am I done? I gotta check, don't I? So in my original equation, are there any values of x that I have to exclude? 0. Okay, so I have to exclude 0, right? We know that x cannot equal 0. Neither of those numbers are 0, right? So we're okay. If none of them are excluded values, then we're fine. You could certainly go, you probably should go back and just check those, okay, just to make sure that they're right. If I plug 2 in, am I going to get the right answer? I'm going to. I'm going to get 1 minus 3 halves is -1/2. Here I'm going to get -2 over 4 is -1/2. If I plug in 1, I get 1 minus 3, which is -2. On this side, I get -2. Yeah, they both check out. You can do it that way too, right? Okay, questions?
How did you, on the left part of it, x squared, multiply with that?
How did I do that? Well, if I just distribute the x squared, I'm going to get x squared minus 3x squared over x. But 3x squared over x is just 3x. Okay. Okay, same kind of thing. Let's do this. So we get 2 over x equals negative 5 over 5x minus 1 over 1. What's my least common denominator? 5x. So then we can just multiply 5x through both sides to clear the fractions. Are there any values of x we have to exclude? Okay, so tan equals 0. So if I distribute the 5x through, I get 10x over x, right? Equals, the 5x's will cancel here, so I get a negative 5 minus 5x. And if what am I going to do here? I've got a 10, so I can add the 5 to this side. I get 15 equals negative 5x. What's x equal to? Negative 3 is not an excluded value, so that's our answer. Okay?
Is that number 19?
That is number 19. Go back to that.
Yeah.
Okay? Okay, this is really a simple one. This is proportion, right? So what do I do with the proportion? I mean, I could do it by clearing the fractions, but an easier way to do it is what? Just cross multiply. So we know that, first of all, x cannot equal negative 1 or negative 4. If I cross multiply, I'm going to get, what do I get with that cross product? 5x plus 20 equals, how about that cross product? So let's push the x's to the right, subtract 10, so what's x? Is 2 excluded value? No, so that's our solution. Okay, and then I think I bet this is the last one. So this one they actually do ask for excluded values. This one looks more like the problems you guys did, right? So maybe let's do this on the next page. A lot of stuff.
For sure. Yeah. Yeah, mine just got out, I can't skip my brother.
All right, so what are we going to do?
Common denominator, clear the
Okay,
fraction.
so what do we have to get a common denominator? What do we need to do here
Factor,
first?
factor.
So we got a factor, okay? So this is going to look like if I factor the whole thing, I'm going to get x plus 6 over x minus 2 equals 13 over x plus 4 plus 48 divided by, what's that factor into? What is it? Times x minus 2. Okay, so my least common denominator is just x plus 4 times x minus 2, right? So right away, what are my excluded values?
2 and negative 4.
Okay. Values must be excluded are negative 4 and positive 2, right? And then I would just multiply that, the least common denominator through both sides, right? So,
Just one of them, right? Or whatever.
well, I gotta multiply the whole thing.
I mean,
So I get, if I do that, let's rewrite that.
would you just
Let me just do it.
do it? You should do it.
All right.
Oh.
So over here, you can see that, oops, sorry. That cancels, right? So on the left side, we're just gonna get x plus 4 times x plus 6. How about over here? If I distribute this factor to the first term, the x plus 4s are going to cancel, right? So from the first term, we're just going to get a 13 times an x minus 2. Agreed? When I distribute it to the second factor, everything's going to cancel, and I'm just going to get a 48. Right?
Yeah.
So then now I just got to solve this equation. So if I multiply all this stuff out, I'm going to get x squared, what, plus 10x plus 24 equals 13x minus 26 plus 48. And if I push everything to one side to put it in standard form, we're going to get x squared minus 3x if I subtract 13x. And then over here, negative 26 plus 48, what's that?
Negative, or positive 22.
Positive 22, so I'm going to subtract 22, and I'm going to get plus 2, right? That's a pretty easy one to solve. What's it factor into?
Negative 2, negative 1.
So what are my zeros?
2, 1. Uh-oh.
Plug them into make sure.
Okay, but, yeah, look at this. So we know because 2 is an excluded value, that has to get canceled. And so my only solution is just x equals 1. Okay? So that's actually a problem you guys, that's on your assignment. That's the very problem you already did on the assignment. It shows up, it was on your test.
Is it
Yeah.
Okay.
Also materials.
Okay, let's see if we can get through just a couple more real quick. We're not gonna probably get through everything, but we get through most. So then there's some simplifying radicals. That looks pretty familiar, right? So what do we do with this? I've got the square root of 45x to the 5th. So we got to break this up. Remember, now please don't get chit-chatting. I want everybody's focus up here. We got to be really efficient. We don't have a lot of time. So what's outside and what's inside from the 45?
3 on the outside.
3 and a 5. Good. Okay, because we could break it up into the square root of 9, which is a perfect square, times a 5. Okay. Now what about the x? Okay, good. So that's an x. The square root of x to the 5th is what as a fractional exponent? 5 halves. Okay, 5 halves, remember, that's going to equal x to the 2 and 1 half. So there's my outside, I get my x squared. Inside, I get my x to the 1 half. So that's my answer, right? Right? Okay. Okay, what about this? Now it says simplify the expression and write your answer with a rational exponent. So it's not wanting radicals, it just wants a rational exponent. Well, what's our property of exponents say about this one? If I divide like basis, what do I do?
Subtract.
Right.
So I get v to the 2/3 minus 1/8, right? 2/3 minus 1/8, I would just have to get a common denominator, so that's 24ths, I guess. So I'm going to get 16 24ths minus 3 24ths. So my final answer is v to the,
13/24.
okay? 13 24ths, no biggie. Okay, what about this? So now this time they want us to write it as a simplified radical. Okay, but remember how we do this here, right? Now because it's a square root, we don't have to do anything too fancy with this. If this were a higher root, we'd want to write the bottom. Hold that thought. We got just 3 left to do. We'll do those tomorrow. And then you can, from that point on, time's your own.